Hi, for those of you who weren't here yesterday, I'm Mike Bartolacci, professor of ISD at the Penn State Berks College. One of our members is missing here, Bill, so we have Ariel and Young. And this is, those of you who heard me asking questions yesterday, some of it is in here, so you'll see them more formally presented. Okay. That's okay then. I said it there. Sorry for, I guess, these small fonts for those of you in the back. Being that I teach courses that are not all data science, they're not all big data, but have pieces in it, I was hoping to see maybe more theoretical content, more introduction of where big data fits in the scheme of things, in the big picture. And hopefully my rest of my group agrees there. As far as like relationships between relational and non-relational database modeling. One of the criticisms of relational database schemes or in general is that it takes too long to process large data sets. And that's hence the reason for the whole non-SQL and the whole need to go to more of a big data mindset. Also expanded introduction to non-SQL approaches. Again, what I just said. I mentioned this yesterday, that I don't think students from a pedagogical point of view can understand where big data fits or why we even have big data unless they understand other approaches or what's currently being done out there in industry. Things like data marts, data warehouses, where do they fit with big data? I mentioned OLAP as well, online analytical processing. And the last one goes along with that. We have transactional processing systems, things that record items that go on in an organization as they happen in a real-time basis. And then we have more of the big data. It's really historical data that's used for managing the organization, right? For making sense, for mining. And I think students need to get a sense of the difference between these two types of systems. Relational database is great for your transaction processing system. It's not that great for huge volumes of data if you're trying to make sense of it. So we were thinking of maybe a little bit of reorganization on this module 1. For instance, the career information. I think that would be the big sell, right? And leaving it till the end, sort of like, hey, this is where you can go with this. Once students have seen what big data is and kind of looked at it, now this is the payoff, right? The big dollars, so to speak. And the simulation examples yesterday were one after another, maybe breaking them apart. I know if I show the same thing several times in a class, I see students like looking down, looking away, looking at their phone, you know, maybe breaking those simulations apart. And let's face it, nobody here probably heard of the term big data 15 years ago, right? At least I never did. What makes big data more than just a buzzword that's going to go away in a couple of years or even a couple of months? What makes it unique? And really what we're talking about is storage is cheap, right? The ability, and the sensor networks came about in that time period too. The ability to record almost anything out there. So those two coming together, cheap storage and the ability to capture anything and everything, leads to these large volumes of data, which gives us the big data. So I think students have to understand what is the genesis of big data. And what is the cutoff point? The questions that I was just asking a little while ago, I believe it was up to what, 10,000 records you mentioned? I mean, I consider that small data. So, you know, big data, you're talking millions, billions of records, possibly. You know, even mine with like 500,000 is somewhat small, but may be considered big data for coming out of the Hershey Medical Center. And I didn't see any mention of companies, you know, that are using big data to their advantage. Students, I think, tend to relate to examples out there, companies they've heard of, you know, maybe companies that they want to work for. I'm not sure if there's any more. Oh, yeah. So, examples of simulation or applications that are business. Most of yours were more physics and things like that, graphical, gaming-like. How about ones involving, you know, non-governmental organizations, government or business type examples? And I mentioned this yesterday too, for those of you who were here. CRM, customer relationship management. I think that's where big data is currently used most effectively, in my opinion. And I mentioned when I brought this up yesterday, casinos. My family, my uncles, founded and ran a chain of 35 stores. In fact, in 1968, Sam Walton came to visit my uncle because my uncle had both food and non-food in the same store. Hence the genesis of the Walmart Supercenter. Now, CRM, my family since have sold off that company, but CRM I could see where it's used in retailing to a tremendous advantage. Being able to profile each and every customer that walks in the door with a little club card or whatever they use to track them. If they're paying with cash and they don't have a club card, okay, maybe you can't track them. But I learned rather quickly that Walmart, if you use a credit card, Walmart doesn't have these little clubs. If you use a credit card or a debit card, they know who you are. They track you by your use of your card. So I think CRM, there should be a little bit of CRM in here because I think it's where it's being currently used most effectively. And I believe that's the end.
Thank you so much for the comment. So we're going to listen to the next presentation.
Okay, thank you. Yesterday we had somewhat limited information as we were preparing for these slides. We hope that this slide will be a little bit helpful. Would like to say something about, you know, good thing first.
Okay.
Make you feel good, and we're gonna bring it down gently, if possible. And I believe that I didn't know about the storytelling, how we can tie that to a big data, and coming here. Not just me, all of us, we understand, we could use a storytelling to teach our students more interest, you know, get some attract attention. So I think program managers provide a good insight of application of big data analytics in classroom, how to make it more interesting. And also we feel that the video provide an example of a good classroom content. We did some exercise yesterday afternoon, draw some pictures, and he did very interesting. I will share that with my classroom.
It's on answer.
But it was a very interesting story. So it was good. It gave me a approach to introduce to my students. Labs enable better understanding how student can be applied to a material. There's some number of improvement we can think of is because we work in different area. Some of us work in business sector, security, the IoT, vehicle area network. How can we fit this module into our courses, our program? How would they do that? I know you just starting. This is first workshop. Something that you could think of. How can we implement this module into our curriculum easily? And another thing is we have a question on what's the overall goal of the project. We know that you guys are using storytelling. You're showing us different tools. What is the overall goal? Which means is Are you going to get into, like the lab presenter, are we going to get into depth? Is it more of a using the tool, getting the high level? My concern is that you introduce all those high level tools, the RapidMiner. And for myself, I'm more of a networking person. When I go back, okay, we have all this tool. What's next? How can we, actually help us? And in this workshop, maybe give us a good goal. Means is are we going to teach the student how to just use the tools? Are we going to do the program in depth? So. And maybe have some more clarity on traditional rational database different from a big data oriented system. What are the differences? And you could talk about that. I think the last presenter presented a little bit about it, comparing theoretical. How is it different? And maybe introducing the real world problem into big data. And I know you touched upon a little bit about security, but what about the other area could be helpful? Healthcare, business sector. I mean, I think you guys doing that, and maybe a little more in depth. I think that having a big data textbook is an excellent start. It's a tutorial, is very excellent start. If you could provide more resources, links, I'll be talking to you a little bit more about it. Where can we get the data? How can we clean up the data? Where the other universities' classrooms we can get access. So we could use that as an example. So all of us are pretty busy. We don't have a lot of time to dig through and all that. If you make us life easier, that will help us to implement this modules and material in the classroom faster, I would think. So I think continually developing the textbook is important, and something that maybe you could distribute to our students. They can look at those and they can do some exercises. And the hands-on exercises, that align more close to the typical rational problems would be helpful. Blender illustrates and demonstrates big data from perspective modeling, complex object. Also, you will help with the example that worked in large data set. I think you made this comment.
Yes.
You want to talk a little bit more about that, or?
It's just, looking at big data with modeling and physical stuff, that was helpful, that was interesting. But most of what I'm usually been exposed to in the past has been when you're talking about data that's more consistent with what you see in a relational database. How do you process that kind of data? So I'm interested in solving that.
Unstructured data sets, those things.
What are the needs of teaching data sciences equipment? And we saw some pretty good tools we can use from online, Jupyter's and RapidMiner. Those are all good. And what are the other tools out there? Comparable tools. It's good to know. What would you like us to work on? One thing is, how can we get the data sets for healthcare, security? Within security, there are a lot of different fields. Do we have to generate the data, or can we get it from somewhere? We don't know where, because we don't have a big data background, healthcare, business. And they'll also provide learning resources for faculty. What would be the optimal way to teach the faculty? Business faculty they have different needs. I'm more technical. I have a different needs and so more in depth. So what are the resources available for those? What about the recommended books? We prefer a lot of the books with PowerPoint comes with it. Are there books out there? And maybe you can use the resources and create more online labs. And not per se you're using it, and we could use that as an example and modify it, implement it in a classroom. It will make us life easier. I think we can do all of this. It takes so much of time. So we're doing a couple hundred things in a semester, it will make it a lot easier. It means we're willing to implement that. A create data analytic community, that is important. But remember that creating is one thing, sustaining is another. So I see a lot of groups and community created, and after a year or two later, it kind of fizzles out. And I would like to, because big data is not going to go away anytime soon. So I would like this community to, share information. Means is I've created a course, maybe share the course, maybe share the labs. And these are the tools used for being able to sharing resources. That will be really nice. We can use RIT resources if you need it. So not all university like Penn State has an unlimited amount of resources. There are some small colleges. Maybe we can invite them, and join and share the resources that way. Yeah, we would like to see more technical example labs and content as well. I guess you guys are working on it. That's it.
So first things, I was bad. I was like my students, and I did my PowerPoint presentation this morning. So, but the interesting fact is, since I've kind of lived this, it's interesting to get the feedback, and I'm very appreciative, and it allowed me to do, I guess, some thinking as far as the improvements are concerned. So, general impressions, justifications again, living it, kind of getting feedback from one of my students and the team. Is the modules, the way they're designed, set up, are they helpful? I said yes. I think they're very helpful.
Otherwise, you're in trouble.
Yeah, otherwise I'm in trouble. And to continue on that, and just from the comments I've heard so far, one of the main driving forces is time, right? This is the first time we're doing it, kind of like the first iteration, so it's the first version. And remember, we're starting the first half of the semester doing relational database management. So we're really truncated, and I'll talk about that. But one of the ways to improve, we've kind of gathered that a better improvement would be the connection of big data and social media. We touched on that, maybe some further details, and we use the exercise to accomplish this, but we think there'd be more exercises. So like you were mentioning, whether it's healthcare, other different businesses, CRM like Salesforce, maybe an introduction to that, because they're one of the leaders in CRM. So those are some possibilities, and additional videos. What I did mention is I actually use a lot of videos in my class, including the Linda videos that JR did for his big data. But it's always great. I think it's a lot refreshing. Students don't want to hear me yammer on forever, so the videos get a little bit of refreshing. What do we want to add? The techniques of big data and the tools being used. I think there could be, again, some introduction of what the tools are, and I think that's some of the things that we're talking about today. So again, just the introduction to that, and then really begin the process of finding careers in big data. So we talk about the careers, where they're at, what they pay, but maybe take it a step further and start to build your resume on skills for that. And then just deeper content, but that all goes back again to the amount of time that we have. And then as a group, we thought about, well, there's so many great things that we're kind of touching on, maybe we should have additional classes to this. So that was kind of our depth of content discussion. Access to ebooks. So again, the way I taught the class was I used ebooks as almost behind the scenes. Now, when the students started to work on the labs, they saw the ebook, but it was never a resource right from the beginning. So it kind of made me think about that as a group, that maybe I should just have that right from the get-go. The course sequence, more classes, I mentioned that. Again, big data is not going anywhere. There's so many different things that we can talk about. So that, and just additional resources, which again, through Module 2, Module 3, all the things that we're working on, we can start to build this great library of resources.
I'm Rachel, and I'm going to share some of my perspective of my teammates is going to share as well, so it's pretty informal. So general impression I have, I've been following the big data curriculum for a long time, and I participate in all sorts of different groups that die, and things, people start all sorts of initiatives, and so my general impression is that I think this is definitely, it definitely fills a niche area in the education industry that has good labs, and it's innovative, and it's bringing all these things that we usually do. Like I usually try to collect all these different materials on my own. I write my own assignments, so like it's really nice. And the book publishers, I think, are in my, I haven't been impressed by any of the textbooks that are coming from Pearson or from Brookhill, and so I think it's definitely something that the book publishers have been unable to provide. So I think that's good. And it's open source, like it's open to the public, and I think that sort of public service is important. That's what we need. However, I do see, and we only have the first module, so it's hard to evaluate right now, but the chapters I see so far, the tutorials, one impression I have is that there's a lot of variation in terms of difficulty, right? So like, for example, the online dating exercise is great, and it's pretty easy to do, it's Google form, but then when you go to the physics exercise, the physics one, it actually comes before the dating one. And so that one, I think, can be quite intimidating for anybody who's not a science major. So that will actually bring to my next question, which is, what's your audience, right? So go ahead.
No, it's very interesting what you just described. I thought it was a little bit funny. So when you went into the modules and you see the physics one, there's several different ones that you can do. And I tell them you have to do the bouncing ball one. Mm-hmm. And then after that, just pick one of the other ones to do.
I know, but I'm not, I don't think the lab, I think the lab, with proper instructions can be actually quite fun, and it shouldn't be that hard. Like Weka and all these other things, they're probably not very hard, but I think they're very intimidating, probably because I teach business school. I am very, very in tune with what my students' fear level is. So, I think a lot of it is, sort of understanding your customer, right? So, and the sequencing of the tutorial, right? So I think there's probably a rationale or a logic for why you do, why, physics is number 3 and dating is number 4, but I don't see that logic very clearly, right? So I think a little bit of sequencing and, sort of stacking and what is level, the first one should be the foundation for the level 2 and so on, but what is sort of the logic that's like, like what is the how did you design this? I'm trying to understand the design principles. And I think somebody was on our table, right? Lloyd was saying that he really wished that he had pre-test results as an instructor so he can learn better about his students. So I think that's just a recommendation to the team. But as an academic, I feel that I need a clear conceptual framework for with academic foundations, right? So this is, and I have seen textbooks like this. Actually, one of my MIs, I think you guys are trying to write an MIS textbook, because we do. If you see my MIS text, the book that we use, it's like, there's a story, it's action figures, it's like a cartoon, book, and there's this, there's a whole chapter on career, so that's what we do right now, and which is, I think it's important, but I also feel like for students to be able to actually understand RapidMiner, to actually understand Weka and all that, I think going back to the academic foundations, the disciplines, statistics and whatever, econometrics and research methods, all these things are very important, programming, so that when they use the tool, because in business schools we teach that a lot, they use the tool but they still don't understand anything. because these are very difficult concepts that people with a master's degree have taken 10 courses in it and so on, and if you think you can just push a button and understand what's going on, that just means that, there's a reason why we make people take all these difficult courses, right? So I think that sort of thinking, really, I'm not saying that this is not useful. I just think that a careful analysis of what academic foundation they need before we introduce these things will be helpful. So theoretical foundations, and sometimes I'm a little unsure about the assumption of the target audience, right? So are we teaching to engineers, the information science students, business students, or anybody, right? And so with or without programming background. So like from a curriculum design perspective, what are the prereqs? What are the assumed prereqs? So a lot of times people say, oh yeah, anybody can do this. Well, are you sure? If somebody has not taken college algebra, can actually understand this, right? So yeah, so like if you have never taken programming, you don't know what semicolon means, then are you sure this person is not going to cry with your Python tutorial, right? So just, things that are very easy to you, math level, right, statistics level, just prefacing, helpful, the preface indicating sort of potential audience, intended goals, and all that. Is that your comment? Yeah. So sort of clarifying all that to the instructor at least, I think will be helpful for us to determine if our students are ready for this. And also, I recommend that I know that you're trying to do a lot of applications, and that's actually what business school is about. It's all about applications. But because the applicant, once you step out of your technical discipline, then the application is like the sky's the limit. So like, I think that the intention is to say, oh, we can do it in dating, we can do it in physics, we can, data is everywhere. But there is actually a framework to it. So I think sort of thinking about how do we systematically pick our topics and examples, and I would use industries, which we call verticals in the business school. Think about your different verticals and think about your different job functions, the horizontals. And then you can start to see, some of your examples are in certain spots, right? And so how do we say, well, maybe we will have a version of the book with all, it's all big data for healthcare, big data for government, big data for whatever. And then all your examples are systematic in that, right? Or quizzes and all the things, so that there's a theme to it. And then, because I know I have a lot of nurses, and the nurses will feel very comfortable if the examples are all about nursing and nothing else. So that, and maybe I know that, but right now I feel like you go from one industry to another, and with unclear sort of job functionalities. And so some people will say, well, I really need CRM. And CRM is really about the marketing, right, function. But then my CRM can be in different sectors, right? So my students, a lot of the athletes will really like the sports data and so on. But, there may be girls who like fashion, and then security is another industry, right? So think about how maybe you want to go a representative, different, you may want to have an example for every industry, so you go to broad spectrum, or you can have different versions, because the nice thing about the ebook is that you can actually say, well, have a drop-down menu, and you can select different examples for different functions. Instructional materials. So when you have an e-textbook, you're really competing with McGraw-Hill, right? So the reason why we make students pay $200 for McGraw-Hill is really because, they give us all the PowerPoint and the quiz book and the Connect and all that, yeah, just something to think about, sort of how to, going back to your point about how to make our lives easier as instructors. Openly available data sets. I actually collect some data set sources that I can share with you. There are data science curriculum frameworks available out there. I actually have collected a few European standards and so on. So I think sort of thinking about comparing how you design your book to these already established frameworks and see how you sort of compare to them and make sure you're consistent. You know, I think if you are able to say, well, we design our curriculum based on this framework, I think that gives a little bit more credibility to your book. So we saw sort of one of the many challenges we have as instructors is, you know, is the server going to work? You know, if we don't have IT support on site, you know, can we still teach this? So, you know, helping us picking and choosing the most reliable tools that would never fail in the classroom is important. So that's how basically my criteria for selecting what to do for my assignments is like it has to work, right? So Tableau always works. So that's why we use Tableau. And also I think, you know, having this community is great. And if, you know, I know we all have ideas, you know, people like CRM and security, we all have like needs, you know, education, maybe big data for education. And so how do we engage everybody, and maybe we can have an open source method and everybody can contribute different labs, right, different examples. Actually with the same data set, you just change the labels of the columns and then you have a different industries, right? So there may be some very easy way to systematically build out labs for different industries.